Now let's get into understanding the mathematical aspect of it. Now this motion which is there is also a simple harmonic motion. So let's get into mathematical aspect where we find y is equal to a sine omega t, where a was amplitude, which we are aware of as SHM, simple harmonic motion equation. Magnitude of E also is equal to E0 sine omega t. This also we have seen, where E0 was EMF maximum. Alright, this was also equal to d phi by dt magnitude. Similarly here, it's angular displacement. From here it would be displacing this way, from here it would be displacing this way by theta, angular displacement, and from here it would be displacing this way, another angular displacement, which would be amplitude. So the maximum displacement which would be there would be amplitude. From here, maximum displacement which would be there would be amplitude. So in terms of SHM, if we try to use an equation, it would be y is equal to a sine omega t. But now here, since we are speaking in terms of angular displacement, so we would be using equation theta is equal to theta 0 sine omega t, where theta 0 is amplitude of oscillation. And amplitude of oscillation, if the magnet is going like this, then the extreme end would be the amplitude, and that would be theta 0. Alright, extreme end this side or extreme end this side would be theta 0. Alright, now having understood these, now let us get into equation. E is equal to d phi by dt. The equation has to be modified with respect to theta, so to vary it without changing meaning. Alright, so what do we do? So our equation E was d phi by dt. Now we divide and multiply it with d theta. So d phi by d theta and d theta by dt. Now when we are talking, so we have got two things to be explained, verified. Alright, now in first case, it is d phi by d theta. This term deals with geometry of setup at theta is equal to 0, its mean position, and flux is maximum as per graph. When it was entering into the copper wire loop, flux was rising, and then flux became maximum and constant when the magnet was inside the coil, and then again when it was coming out, at that time again the flux kept on reducing as it was coming out, so flux kept on reducing. So what do we mean? So mean position is somewhere here means maximum. So at theta 0, and theta 0 means it's at mean position, so at theta 0 it's mean position and flux is maximum as per the graph. So that part is understood. Alright, now let us pick up the second part. Now in the second part, theta is equal to theta 0 sine omega t. Alright, so now what we do is we differentiate it. This is what we need. Alright, so we differentiate it with respect to t. So this is what we get. Sine gets cos, and we know that one of the constant term comes out as per a rule of differentiation. The constant thing comes out. Alright, so as per chain rule, because we are differentiating, first we are differentiating sine omega t, for which we get cos omega t, and then we, as per chain rule, then we differentiate omega t, d omega t by dt, or we can also call it as omega dt by dt. So dt gets cancelled, so one omega remains, that omega is out here. Alright, as per differentiation. So ultimately what we end up is with theta 0 omega cos omega t. Now we also know that omega is equal to 2 pi by t. So we substitute there 2 pi by t and theta 0. So cos 2 pi by t into t, 2 pi by t, and this is this t. Alright, so now let's make this theta. Alright, so again because we know that theta is equal to omega t. So this is omega and this is t, and that is theta. So we again convert this into theta. So and then we come to 2 pi theta 0 time period t cos theta. Now when would this value be maximum? This value would be maximum when the value of this gets 1. Alright, and when does it get 1? Cos 0 is 1. So when theta is equal to 0. And when is theta 0? Theta is 0 at mean position. So again, for this also we get maximum value for theta is equal to 0, and for this also already proved we have maximum value at theta is equal to 0, because at theta is equal to 0 the flux is maximum. So for this we already proved here that it is maximum, and for this also right now we are proving that at theta is equal to 0 the value would be maximum. Alright, so d theta by dt would have maximum value 2 pi theta 0 upon t when theta is equal to 0. Alright, theta is equal to 0 at mean position, that is when the magnet is inside the coil. Alright, so now let's get back to our original equation. What we need here now, see, now we have changed it from E to E0, as I presented earlier that E0 is maximum value, I0 is maximum current, E0 is maximum EMF, theta 0 is maximum angular displacement, which is amplitude. Alright, so getting back here, so mod E0 is d phi by dt max when theta is 0. Theta is 0 means it's at mean position. D phi by dt max we need, so we d phi by dt we need is max. For that this has to be max. We know when it is going to be max. It would be max over here at mean position at theta is equal to 0, and then for this also it would be max 2 pi theta 0 upon t. That is what we found. Alright, okay, so this is the formula. So from this what do we derive? We derive that EMF is directly proportional to angular amplitude, that is theta 0. Alright, is directly proportional to angular amplitude, and E0 is inversely proportional to time period. What do you mean by inversely proportional? Time period. Now when you do time period, time required for one oscillation, one complete oscillation. Now when I say time required for one complete oscillation is, this is first case of oscillation and this is the second case of oscillation. Where do you feel the time period is less? Of course in the second case the time period was less. So lesser the time period, that itself means when it is moving fast in this, the EMF would be maximum. And second thing is proportional to theta 0, amplitude being greater. Amplitude being, when would amplitude be greater? When number of turns are more, then the amplitude would be greater. So more number of lines would be cut, and as a result of that EMF generated also would be more. So if these coil which we are talking about, these wire loops that we are talking about, if we increase the number of loops, then the amplitude would be more, and since amplitude would be more, EMF generated also would be more. So number of turns increase and time period reduce time period in the sense moving faster. Alright, so these are the two factors which would generate more EMF. Alright, so see how we found that a moving magnetic field can generate EMF. In other case, we saw that stationary magnetic field would generate EMF in moving rod. So there it was moving rod, rotating rod, and here it is the moving magnet, oscillating, rather I would say oscillating magnet. Alright, I hope you understood this. Alright, all the best.